Very good morning, one and all. Welcome to our subject, artificial neural network. And today we are going to discuss backpropagation neural network. And if you remember it, in the last class we had a discussion about feedforward neural network, how the neurons are going to be work, what are the inputs you are giving, and what will be the outcome of hidden each and every hidden nodes, and finally how it will reach to the output, and finally once you will get the output, then what is the targeted output. Finally we are going to calculate the error, whether your model is going to be well trained or not. Once you know the error, then how you are going to reduce it, what is the use of backpropagation, why it came in the pictures. You already given some input, it will pass from the neural network, hidden layers, and finally it will reach to the output layer. But that output is not exactly what we are expecting. Some error you are getting. So what you are doing, that model outcomes and the desired outcomes, both you are going to subtract it and you are getting the error. That error, we are going to reduce it with the help of backpropagation here. Because that error is going to be contribute how much in each and every node with respect to their weights. That we have to find out with the help of backpropagation. That only we are going to discuss. And in the last class, we assumed one example, we took one example. The same example I am going to carry forward so that all of you can correlate that, yes, this was the outcome yesterday, we got it, and now how we are going to reduce that error. Right, with the same example. Now I will come here, we know that again the backpropagation is a supervised learning method, supervised learning algorithm, right, that we know. Why we are going to use it, that also I told you that once you are getting here error, that error you are going to reduce it. How you are going to reduce that error? For that purpose only we need this backpropagation. How you are calculating? Here also I mentioned that formula, the prediction minus actual whole square, that's it. Now if you recall, in the last class we had a discussion on the same example. There were two inputs, x1 and x2. On the screen it's very clear, this one is x1, this one is x2, and the values are given 0.35 and 0.9. If I am talking about the hidden layer, so here I mention it, hidden node 3 and 4. Because 1 and 2 I consider for the input, 3 and 4 I am going to consider for the hidden node, and 1 I am having the output node, O5. And with respect to that, all are the weight values. 1 to 3 means this weight value 0.1. 1 to 4 means input 1 to hidden node 4. 2 3 means input to hidden 3, and 2 4 means 2 to 4. All these weights are given. In the same way, H3 to O5, H4 to O5, all these weights are also given. So I mentioned there W35 and W45, and we got it here Y5. This was the example. What is our targeted output here? If you remember, if you recall it, 0.5, and my learning rate I consider it here 1. Yesterday also I told you that learning symbol is neta, and that we are representing maximum learning rate with the maximum efficiency we want to train our module. That's why we are assuming the maximum learning rate here, right? So how you calculated the error? Once again I will give a small glance so that you can recall it. So what is the output of this H3 node? If you will see H3, how you are going to calculate here, and yesterday also I told you that each and every neuron is going to be work in two phases. The first phase is summation phase, and the second phase is the activation function. If I am talking about the summation phase, so what is the formula there? The weight values into input x1, the weight values 2, 3 into x2, and all these values are given. So what is the value here? You got it 0.755. And when you will apply the activation function, which one? Sigmoid function. Sigmoid function normally we are using it there. So what is the formula for sigmoid? If you remember it, here also I mentioned 1 upon 1 plus e power minus j. So when you will apply this formula, this minus aj is nothing, that summation value just now you got it, that you just put it here and you will get 0.68. In the same way, we can calculate a2. Just now what you calculated y3, a2 is with respect to y4. So here a2 and then y4, and here a1 and y3. So what is a2? W124 x1, W24 into x2. These formulas, it is well known to everyone. So 0.4 into 0.35, 0.6 into 0.9. So finally we are getting here 0.68. Once you know this summation value, again we are applying the activation function, sigmoid function, same that formula we have. When you will apply it here, you will get 0.6637 value. So we got it y3, y4. In the same way we will calculate for y5 in fact, and that I am going to consider as a3. Summation is a3. So that equation is well known to all of you. All these four values, once again we know it, right? When you calculate it, we got it 0.801. Once you know this summation, that everyone knows, that we can calculate this 1 upon 1 plus e power minus x. And what is x? 0.801. When you will put it, the last time also we got this value 0.69, right? This is the module outcome 0.69, right? But what is the targeted value? In the starting, if you remember it, I mentioned it there, 0.5 minus 0.69. So what you are getting here? 0.19. This is the error. That's what we discussed in the last class. And now this error, how it's going to be contribute with respect to all these weights. How many weights are there? Overall 6 weights are there, and how it is going to be divided in each and every weight. This is the first, second, third, fourth, fifth, sixth. So what are the weight values are previously available? We are going to change it with respect to this error. That is the main task. So if this small error, how is going to contribute, how much is going to be contribute for each and every weight, that we have to see. That process we are calling as backpropagation. Now when I am going with the backpropagation, you should remember these three important things, these three important formulas. How we are going to check it? Delta ji, that is learning rate, right? This one is the error measurement of j and output of that particular node. How you will calculate this delta j is nothing, output of that node 1 minus output of that node, targeted minus output of net. When this formula you should consider? When output is on the output layer. That node will represent in the output layer, then only. If any node is lying in the hidden layer, that time the formula is going to be changed. This oj is same, 1 minus ojo, output of that particular node is same, and here weight into delta k. In the same example, when I will apply, I will discuss all these things step by step. Now just now we had a discussion what is the final error, and we have seen that what is the error we got it, 0.19. Remember this, because later on with the help of weights I am going to reduce this error. That's what ANN is doing, artificial neural network is doing. Every time it is going to update the weight values, and finally it will get the desired output whatever we required. Now can you tell me this error is going to contribute on how many nodes? Yes, 3, O5, H3 and H4. So that's what I am writing here, delta 3 with respect to 4, delta 4, and with respect to output layer delta 5. These are the three. That's what we are going to compute it here. That's I mentioned there, delta 3, delta 4 and delta 5. Now when I'm going to calculate it first, O5, because here we know the error minus 0.19. So this error, how it is going to be contribute on H3 and H4. So what is the weight values of 3y, what is the weight value of 4, 5, that we will calculate first. Now delta 5, if you want to calculate, we have seen that formula y minus 1 minus y. Y is nothing, output of that node. That's what I mentioned the last. And what was the output of this? We know that is 0.69. 1 minus 0.69. Y targeted, how much was the target? 0.5. And what will be the output? 0.69. When you will put it, minus 0.0406. That's what we got it, delta 5. Now for hidden unit, for delta 3, in the last slide I mentioned two formulas and both of them I am going to use it. This one is when your node is present at the output layer, and this one when your node is present in the hidden layer. Now just have a look here. Delta 3 is nothing, y3 into 1 minus y3 into w35 comma delta 5. 0.68. y3 we know that with respect to this already calculated while feed forward neural network, 1 minus 0.68, and this w3 is nothing, we know that w35 weight value 0.3, and this value just now we calculated because this delta 5 only is going to be contribute here, because that error is only going to divide it into two parts, w35, w45. So with respect to that, 265 is contribution by delta 3, and in the same way delta 4 is nothing, y4, 1 minus y4, w45 delta 5, because w4 is also contributed by the delta 5 only. Now all these values we know. What is about your y4? 6637. So that value we know, 1 minus 6637 into 0.9 is the weight values, and delta 5 is nothing, minus 0.0406. So what you are getting here, 0.0082. What you calculated, all three values we computed, delta 3, delta 4 and delta 5. And one more thing, yesterday if you remember that when we calculated those values, I told you that minimum 6 to 7 digit decimal values we should consider when you are going to calculate feed forward neural network. The reason is when you are going to see the error contribution, this is the error contribution on the first level. Now have a look here, error contribution is 0.0082. that is the first level. If we have number of hidden layers, now can you imagine that how many zeros are going to be added there? Minimum 5 to 6 decimal zeros, 0.000012 like that. So that's why I told you that we should consider 6 to 7 or 8 decimal value so that it will be more accurate. Once we know these W3, W4 and delta 5, delta 3, delta 4 and delta 5. So how we are going to calculate new updated values? Now what is that formula? Delta J, because so far we calculated only delta small omega Ji we didn't calculate it, and for that is formula is learning rate, delta and output of that node. With respect to 4, 5, if I want to calculate it, means I am talking about this node H4. So how much changes in the weight? Learning rate by default 1, that's we mentioned. Delta 5 we calculated. Y4 that also we know. All three value we know. So what is my delta omega 4y? 0.0269 minus. And what is my new weight values? Simple formula, old weight plus new weight. So what is the new weight? Minus 0.0269, old weight is 0.9. So finally I got it here, new weight value is 0.8731. So I calculated only one weight values, this one, 0.8731. With respect to that, one more weight values I am going to calculate so that you can get the clarity here, and rest I will show it. Delta omega 14. What is that? This one. This one I am going to check it. Randomly I took. What is the formula? Neta delta 4 x1. Right? So what is that formula? Learning rate 1. This output that we know that delta 4 you already calculated 0.0082 into 35. 35 is what? X1 values. And when you will multiply, you will get it minus 0.00287. Once you know the small changes in the delta omega 14, so we can calculate the new W14 value. Previous value plus new small changes. So when you are going to add it, the small changes plus previous value 0.04, so you will get it 0.3971. So like that, how many weights we have? Overall 6 weights we have in that circuit. So 2 we calculated, this one is the second one, this one is the third one, this one is the fourth, this one is the fifth, and this one is the sixth. Overall these are the 6 weight values are there. Right? 2 we calculated, rest of them directly I calculated here with respect to 1, 3. Now if you just have a look here, with respect to 1, 3, the weight is 0.1, delta value is this, xi is this, learning rate is this, so new updated values are this. 2 weight values we calculated. What are those values? 8731 we calculated in the previous slide. If you will see there, 8731 and 3971. Another is 3971. Rest of the 4 values also I calculated here. Overall, if you will see, 3 plus 3, overall 6 values. With respect to 1, 3, 2, 3, 1, 4, 2, 4, 3, 5, 4, 5. This process will repeat until unless all the weights are not going to be updated. Once you know the new updated weights, once again we will go with the feed forward neural network. Feed forward neural network. Because now new weights are there, and based on that only I mention all the new weights here: W13, W14, 23, W24, 35, 45. I just changed the weight values. While changing the weight values, now we can observe once again what is the error you are getting at last. Again the same formula. Everyone knows that what is the formula of H3, how you are going to calculate. H3 means X1 W13 plus X2 W23. This is the formula. That's what all these 4 values we know. Again we can calculate it, put all these values, you will get 0.7525. This is the summation. When you want to find out the activation of this sigmoid function, again we are going to use 1 upon 1 plus e power minus a1. a1 just now you calculated, you will put, you will get 0.6797 value. So with respect to H3, again you calculated the Y3 here. Now I am going to calculate it here, Y4. What is my Y4? On the same formula, what is the equation for H4? Can anyone tell me? X1 into W14 plus X2 plus into W24. And all these 4 values we know it here. Put all these values, you will get 0.6723. And once again you will apply the activation function on this sigmoid function. This is nothing sigmoid, and you will get 0.6620. This value you know, this value you know. So can you calculate this node? Yes, obviously we can calculate it. Y35, Y3 plus WY45, Y4. All these 4 values we have. So once again, if you will put all these values, you will get 0.7. And once again, if you will apply their activation function, activation function, you will get 0.6820. What was the previous error? Sorry, previous value is 0.69, if you remember it. But while changing the weights, now we reduce this up to 0.6820. So what will be the error there? Targeted value is 0.5 minus here 0.6820. So what will be the output? 0.182. Now previously it was 0.19 and now 0.182. Approximately 0.1 we reduced, 0.01 we reduced it. So this iteration process will goes until unless you will not get your optimum value near to the 0.5 only. This is the way how backpropagation is going to be work. Right? So hope so everyone will get the clarity about the same. And this was the same example. In the last class also we had a discussion how the feed forward is going to be completed. What is the desired output? 0.01, 0.99. We calculated the error also. We have seen this example very carefully and we got this error. And how this error is going to be contribute, how with the help of backpropagation we are going to calculate the all new weight values, W5, right, W6, W7, W8. So I calculated all, and finally the way how we can calculate it once again. Once you know all these values, so W1, W3, W4 also we can calculate new weight values, again feed forward neural network, and this iteration will goes up to the end. This is all about the backpropagation. Hope so everyone understood the concept. So in the next class we will come up with the one more topic, new topic we will enjoy. Thank you very much.